All right, are you ready for some FUN? Because we're going to have some this week. You're going to write 3 argument constructions this semester, and this week we're going to tackle the first one. So fun stuff ahead. So what I want to do in this video is I want to go over that assignment, point out some of the things that people do that oftentimes causes them to result in losing points needlessly, talk about some strategies for how to address each problem, and point some things out so that you can complete this thing successfully. So the very first thing you need to do, if you haven't done so already, is you want to download a copy of that assignment prompt by clicking this link here. That'll take you to a page where you'll see the assignment, and you can also download a Word document for yourself so that you have it on your computer, because you can complete this assignment in one of 2 ways. You can either type up all your answers in this document that you've downloaded here and submit that typed up document, or you can print it out as a paper copy and handwrite all your responses to the questions. You just want to make sure that you write really clearly and legibly so that I'm not wondering whether or not you've answered the question correctly. All right? So make sure you have a copy of that on hand. The other thing you want to do before we move any further is you want to make sure that you have something to take notes on. If you've printed a copy of that assignment prompt, that is the ideal thing to take notes on, because we're going to go over it and you can write yourself little notes on it as you watch this video. If you don't have a paper copy of that, just make sure you have a sheet of paper and something to write on so that you can take notes. So if you don't have that, pause the video. When you're ready, come back and we'll rock and roll through this assignment. All right, so argument construction number 1. There's a couple of things that you want to take note of right away, and that is this argument construction has 3 problems on it. 3, just 3. That's deceptive. It's 3 problems with a lot of sub-questions in those problems. But there's three arguments you have to create. You're going to create your own arguments using your own language on various topics. And as you do this, you're going to want to keep in mind that you're operating here from the Aristotelian standpoint. That means that the traditional square of opposition is in play here, not the modern square of opposition. We are not concerned with Boolean standpoint at all for this assignment. We're totally thrown in with the traditional square and the Aristotelian standpoint. And so you'll want to keep that in mind, because all of those rules like subalternation and contraries and subcontraries, they're in the mix for this assignment, so you can use them. The other thing you want to keep in mind is that with the Aristotelian standpoint, we do our Venn diagrams just a little bit differently, and that is a common place where people screw up, is they forget that they're working from the Aristotelian standpoint and their diagrams their Venn diagrams don't reflect that. They'll do Venn diagrams that reflect the Boolean standpoint. So there's your first note to take to yourself. All right, the other thing you'll want to take note of is that you want to read the directions for each problem really carefully. I can't tell you how many points people needlessly throw away simply because they don't read the instructions carefully. Sometimes I see people doing this in their thought primers too, where they just don't read the instructions, and then I have to give them a nastygram that says something like, go back to your book, look at those instructions really carefully so that you do the problems correctly. So make sure you're looking at each problem really closely, really carefully. All right, so problem number 1 says this. What is the standard form ordinary translation of the following statement? 2 things to take note of here. Standard form. That means your translation has to be an A, an E, an I, or an O claim. Okay? Second thing to take note of, ordinary language. Ordinary language means you're going to be using words like I'm using right now, words just like the ones you see on the page in front of you. You're not going to be using symbols yet. Okay, so you want an ordinary translation of this statement. There's no such thing as a logic student who's not a rascal. You're going to write that statement down right there. And then once you've got your answer, you get to move on to number 2. And number 2 says, assume the standard form statement you created for number 1 above is false. And then use the rules of conversion, aversion, contraposition, contraries. You pick. Okay? And you want to create 2 other statements that are also necessarily false. Now, the way that people screw up on this problem is they forget that they're trying to create another statement that is also false, or 2 other statements that are also false. Okay? What that means is if that original statement that you have is false, you want to create 2 others that are false. Oftentimes people sort of forget that the original statement is false. They think it's true, and then they don't come up with 2 false statements for this one. So your original statement is false, and you're looking to come up with another statement that's false. And remember, when you use your rules of contraries or conversion, when you use those operations and rules correctly, you carry that truth value along with you. Okay, it goes right to the next statement. So if your first statement was false, the next statement you create using those operations correctly will also be false. If your first statement was true, then the next statement will be true as long as you're using the rules correctly. All right, number 3 says identify the rules that prove the statements you created in number 2 false. And you're just going to say something like, well, I used aversion or conversion or whatever. Maybe you use two different rules. You say like, oh, I used contradiction and then I used subcontraries or whatever. So you just want to identify those rules. No explaining here necessary. Number 4, this one can be a little tricky, so think about this. Assume the standard form statement you created for number 1 above is false, and then use the rules of conversion, aversion, etc. to create 2 statements that are necessarily true. Okay? Now I'm going to give you a hint on this one. Got your pencil? For at least one of the statements you create, you're likely going to have to use 2 operations, okay, or 2 rules, or some combination of rules and operations. So remember, when you apply the rules correctly, you're going to have a known truth value that follows you from your first statement to your second statement. If you use the rule of contradiction and you start with a true statement, you know the next statement you've created is going to be false. And as long as you keep using these rules correctly, so I take the contradicted statement and now I apply aversion to it, and I can apply aversion to anything. Now I know the next statement is also going to be whatever that original statement was. And I get to carry these truth values along with me like they're in a little wagon, as long as I apply the rules and operations correctly. But the moment I misapply a rule or operation, it's like the back end falls off of that wagon and I lose all of my truth values and I never get them back. Once I have a logically undetermined statement, I never, ever, ever will know the truth value of any successive statements again, even if I continue to apply rules correctly. All right, so number 5, identify the rules that prove the standard form statement you created true. So you'll just say like, oh, I used, aversion and conversion or whatever. All right, now number 6 can really trip people up. Okay, number 6 says this: create a labeled Venn diagram that shows the standard form statement you created for number 1 to be false. Okay, so the way that people mess up on this one is they create a Venn diagram that shows their original statement to be true. So you're going to have to do some thinking on this and maybe reflect back on some of the things we've done with that phrase, it is false that. How can I create a Venn diagram that will cause somebody to look at this and say, oh, you know what? That statement you created for number 1, that's not true according to this Venn diagram. Okay, so think really carefully about number 6. And number 7 is this is probably the hardest question on this assignment so far. Explain how the Venn diagram shows that statement you created for number 1 is false. Ooh, so you want to think about this and put yourself in the role of, you're sitting in the classroom, like I wish we were. You're sitting in the classroom and there's somebody sitting next to you and they're saying like, I don't understand how your Venn diagram shows that original statement to be false. How would you explain to that person? You might do something like, look, and put your finger on the paper. It's like, look at this thing right here. Here's what that means. And if it means that, then this is the case. All right? So think carefully about how you're going to explain how your Venn diagram is false. All right. Now, problem number 2 is a little bit different. Answer the following question with a single standard form categorical statement. What is one thing every person should either do or see before they're 50 years old? All right. So think about that. I want to know, what do you think? This is your judgment here. What's one thing everybody should do before they've reached, halfway to 100? And you're going to write that down as a standard form categorical statement. Now you'll notice here that it doesn't say standard form ordinary language categorical statement. And that's because I'm totally fine with you writing this out symbolically as long as you tell me what the letters refer to. So if you're going to, say like, visit a mountaintop of some kind, I want to know, okay, M stands for mountaintop of all mountains identical to whatever, okay? So make sure that you are, you can write it out in ordinary language too, if that works better for you. All right, then the second question, sort of similar. Assume the standard form statement you created for number 2 above is true, and then use the rules of conversion, aversion, to come up with 2 statements, 2, that are logically undetermined. Okay? How do you create statements from true statements that are logically undetermined? You break the rules. Okay, now, number 3, explain why the truth values. So let me understand. How did you come up with those 2 logically undetermined statements with logically undetermined truth values? What did you do? And how do you know that those are logically undetermined? All right, number 4, take note. Another place where people can kind of lose track of what they're doing. In order. If you avert, then subalternate, then convert, then contrapose the standard form statement you created for number 1, which would be the statement right here about what somebody should do before they're 50. I lost my place. what statement results. Okay, now the way that people mess this up is that they do all of these steps in order. Well, there's two ways they mess it up. They do all of these steps in order, and then they just give me the final statement. And then I think like, well, I wanted to see all your other neat work. So take note of one thing. You want to show me, you're going to have a total of an original statement, an aversion, that's 2, a subalternation, 3, conversion, 4, contrapose, 5. So you're going to have 5 statements here, right on top of each other. And this might be easier to do if you represent those statements in symbolic form. It's way easier to keep track of, and it's less writing for your hand, less typing for your fingers. Just again, make sure that we know what the letters that you're using refer to. All right? And then you want to remember this. The truth value that you begin with, true, will stay with you until you do contradiction or until you use a rule in a way you're not allowed to. Then you lose it forever and it becomes logically undetermined. What was the second way? There's another way that people mess this one up. What was it? Okay, they don't write out all the things. They don't do this. Well, shoot, now you're just going to have to live with the mystery of the second way that people mess this up. Because there is another way, and now I can't remember what it is. Maybe it'll occur to me later. All right, so number 5, what's the truth value of the final statement you created for number 4? It's either going to be true, false, or logically undetermined. And then number 6, create a labeled Venn diagram. Labeled is important. You get points for that, so don't lose the points for not labeling your Venn diagram. Create a Venn diagram for that one that you're showing your statement is true. Explain why this Venn diagram shows that statement to be true. And then we get to something that's kind of interesting. Number 8. Why do you think that statement you created for number 1 is actually a true statement? Now, here's how people will mess up. They'll start referring to the rules, like, oh, contraposition or conversion. And it's like, no. You're doing kind of some of the stuff we've practiced, like the Seth Rogen question. Seth Rogen, an actor. Okay, why do you think it's true he's an actor? And if you say something like, I saw him in a movie, it's like, no, that's not going to cut it. I don't know that because you saw him in a movie, that's compelling evidence that he's actually an actor. What a lot of folks did for that question is they're like, look, I went to IMDb, and this is what it says. Not just that he won Oscars, but he won Oscars for his role as an actor. Okay? Or here's the movies he's been in. I think one of you, I can't remember who it was, one of you put a bunch of pictures of like DVDs or videos that show he was an actor in something. All right, and then number 9 is an important question because people oftentimes mess this one up too. Why might others disagree that the thing everyone should see or do that you identified in statement number 1 above, why would they disagree with that? So you say something like, oh, I think everybody should visit the Mad River Hatchery before they're 50. Why might somebody scoff at you and say well, I'm not going to do that's not worth doing before you're 50. I don't think everyone should do that before they're 50. When I lived in Arizona, up in northern Arizona for a number of years, every year the statewide newspaper would publish interviews with people who had lived in Arizona their whole lives and had never visited the Grand Canyon. And of course the question is, well, besides the fact that you're an idiot, why haven't you visited the Grand Canyon? And they'd say this, well, I've seen pictures of it. So if you've been to the Grand Canyon, you understand why that is a dumb statement. So in number 9, you want to kind of put yourself in the shoes of somebody who's going to think about your suggestion of what you think somebody should do before they're 50, and they're going to kind of scoff at you and say, I disagree. I do not think that's worth doing. So it really forces you to get into this question of value. Why is this thing that you say people should do or thing that people should see, why is it worthy? Why is it, what's its value? Why is this thing worth doing? And why is it worth doing before you're 50? Because somebody might say no, that's much better to do when you're 60 or something like that, along those lines. All right, so I'm going to pause this here, and then I'm going to do another quick video where we go over problem 3, and then you're going to be ready to rock and roll.